Hey everyone, thanks for joining us for the second workshop on developing smart contracts on Koinos. My name is Ron. I'm one of the co-founders of Koinos Group, which is the company behind the Koinos blockchain. Joining me today is Steve Gerbino. He's one of the blockchain architects, engineers that developed the Koinos blockchain. We are now developing a product called Koinos Pro. It's free to sign up. You can go to koinos.pro to sign up. It's basically tooling for developers to easily develop on Koinos. It's free to join, so I encourage everyone to hop in. So today we'll be doing a tutorial on how to develop a smart contract that writes data to the blockchain and retrieves data from the blockchain. We're going to use a to-do list to demonstrate that, even though a to-do list is not a good use case for blockchain, but it'll demonstrate how to store data and retrieve data from the blockchain using Koinos. So in the last tutorial, I went through how to create very basic smart contract and set up the development environment. If you missed that, there's a link in the documentation. It's also on our website, learnkoinos.xyz, this tutorial. But let me post this in the chat here for everyone. And there's a link here to the last tutorial, which goes through setting up the dev environment. So one of the important things that I wanted to emphasize in this workshop is understanding the Google protocol buffers, which is what we use in Koinos to enable communications between the smart contract and the blockchain and the API. It's a buffer between the smart contract and anything that exists outside of the smart contract. So making API calls or writing and reading from the database goes through the protocol buffers in order to translate the bits into something that the blockchain and the smart contract can understand together. I think Steve can hop in here for a second and expand on why we use protocol buffers and what they do.
Yeah, hi. So protocol buffers is a library created by Google that serializes and deserializes structured data. And so your smart contract runs inside a WebAssembly virtual machine. And every time we need to pass data into or out of the virtual machine, we do that in bytes. And protocol buffers allows us to deconstruct and reconstruct structured data in and out of the VM. A couple of examples of crossing that VM threshold would be from a client on maybe on a front-end website. You would want to send arguments into a function. And so you would serialize the arguments using protocol buffers. Then these bytes get passed into the virtual machine and your entry point would be called, and the bytes would then become deserialized back into an object that is usable, or the arguments that you defined for your virtual machine. Another example would be communication between two smart contracts. So when you call another smart contract, it will go out to the blockchain, to the core code. And so you would serialize the arguments for that call, pass those bytes through to the blockchain core code, and that code would then call a next smart contract with your arguments, and then it would be deserialized in that smart contract. And finally, the database, which is the blockchain itself, in the end, it's just storing bytes in key value pairs. And so a good structure for those bytes would be serialized protocol buffer. Yeah, the bytes from serializing an object using protocol buffers. So, essentially the object gets created inside your smart contract. You would serialize those bytes and call a system call, which would pass the bytes outside of the VM and store it in the ledger. So this diagram here illustrates basically that protocol buffers is the translation layer in and out of your smart contract. The reason we use protocol buffers is because our virtual machine is WebAssembly, so it supports any language that can be compiled to WebAssembly. Currently, we have C++, C, AssemblyScript as all languages you can use to write smart contracts. These languages need to communicate with each other in a structured way. Protocol buffers is designed to do this. It's widely adopted in the industry. There's libraries for all languages we would ever want to support. And this also applies to languages, that are not smart contract languages. Maybe you use JavaScript to call smart contracts, or even Ruby on Rails, or whatever the case may be. There are libraries for protocol buffers in all these different languages, and this is basically the main language for passing data between all these different clients, smart contracts in various languages, and it just so happens to be a great way to store structured data in bytes.
We'll just jump into this. I'll run through this. So the first thing that we want to do is create the file structure for writing the smart contract. And we do that by using the Koinos SDK AssemblyScript CLI. If you don't know how to install this, in the first tutorial, I went through on how to set that up. And you should be able to do that relatively easily. So we'll run this command and it'll create it'll create a to-dos directory for us. So we're just going to cd into that, and we'll see that it created a bunch of files and folders for us. So the first thing we need to do is run yarn install. I just use yarn, and it'll install all the dependencies for us. Once the dependencies are installed, we can then very quickly, it creates a boilerplate smart contract, which is basically just a hello world. And then we'll be able to compile that and do a quick test on it just to make sure that everything worked fine and nothing is broken with the installation. Let me just this. Okay, so now our dependencies are installed, and we can build the boilerplate smart contract. So we use yarn build, but we don't want to release. We want to debug. So it should do its thing now, and if there are no errors, we'll run the test. There is a test suite here that you can use to write tests and then test your code. And we'll just run the basic tests right now just to make sure that everything worked fine. So all our tests passed, and we were able to build the very basic smart contract. So now we'll jump into the code. Our goal is to create a smart contract that accepts a to-do item, writes it to the blockchain, and then another function that calls, that reads that data from the blockchain. So just basically two functions, but it'll teach us how to write data to the blockchain and how to retrieve that data from the blockchain. So let's jump into the code here. So you can see that there's a lot of stuff here that was automatically generated for us by the CLI. Really, we're only going to be touching a few files, I think like 3 files. An important one, the most important one for me, is the proto files. This is where we define our entry points and how the functions will accept the data through protocol buffers. So this is what we need to create. I'll just copy it into the code and then we'll go through it line by line. So what we first do is we want a description. We want a description to add the to-do list item. and we issue you'll see a pattern here where there's a message, and it has an argument and a result, argument and result. And then here we define our data object. So the first thing we want to do is define the argument for the add to do, which is a string, and we called it task. The number one is a protocol buffer. It's just to identify different arguments in the protocol buffer, and yeah, that's basically all it is. In our add to do function, we're not returning anything on the result, so we just leave it empty. In our get arguments, we don't really need to pass anything, so we leave that empty. And then we use a repeated string to grab the to-dos. And then the object, we'll get into the object definition in a little bit. So once we created the proto file, the CLI is designed to auto-generate some code for us that we can then use in our smart contract. So let's do that. Koinos CLI, don't we use yarn? We're going to build the contract again. And this time we're going to get an error, which is expected behavior. We haven't written any TypeScript code yet, so the CLI is looking for the correct TypeScript file. We'll get to that in a second. But if that's the only error that we get, this C add or your function error, we're good. So let's look at our boilerplate TypeScript file. So here, CLI generates this boilerplate code for you that you can then add the functions into and then put it in the to-dos TypeScript file, which is what gets compiled when we build it, when we build the WASM file. But before we do that, we need to set up our data, our storage. So we need to create in our assembly folder, we need to create a state folder. Within that state folder, we need to create two files. So the first file is space ID. Which is, it just defines our storage space IDs. You can have multiples of these, so you can have a whole bunch of different space IDs with different names, obviously. But for this tutorial, we only need one. And then the next file we need to create is the to-do storage TS. This is where we'll let me make sure that I wrote it down correctly. Yeah. This is where we'll define our constructor to be able to interact with the database. It doesn't like these are just for indents. So here we're just defining a constructor that will take in our data and then decode and encode it. We will be using that in our smart contract file. All right, so once that's done, we can jump right into the meat of the smart contract, which lives here in the todos.ts. Again, I'll just copy this code into here and then explain it and then do some explanation. Everything is in this tutorial. So we import our stage from our storage from the storage file we just created, so we can use it. We will need the contract ID, as once we compile the WASM file, we want to attach it to our contract. We want to attach the contract to the wallet, the wallet address. All right. And then we need to use the storage as well. So in our first function, which is add to-dos, we add these two argument, this argument to from the protocol. Remember, in the proto file, we define this add to-dos and add to-do arguments and then results. So we first retrieve the to-dos object from the chain state, store them in a variable so we can use them here. If if the to-do object doesn't exist, we'll create a new one. If it does exist, then we'll just move forward and add that to the to-dos array. The next thing we want to do is we add the task to the object by pushing it here. And then once we do that, then we're able to store it by putting it into the to-do storage. And then we don't need to return anything, so there's an empty result. So that's the first function to add the to-dos. The second function we want to define is to get the to-dos. So this one is a little simpler. Again, we add this argument that we defined in the protocol with the proto buffer file. And then the first thing we want to do is, again, grab the storage object, and then again make sure that if the object doesn't exist, we instantiate it. And then all we have to do is get the information from the blockchain. So we call I'll get the get to-dos results. And then we pass that the response into the tasks to-dos object. So once we have all of this defined, these two functions, basically our smart contract is ready. So we can compile it again to see if there are any errors. Now, this time there shouldn't be any errors. Yep, and it compiled. No problem, it compiled. So usually you would, I'm not going to go into writing tests here. Usually you would write tests just to make sure that your code is sound. This is a very simple example, but I highly recommend to write tests. Maybe we'll do an additional workshop just on tests. But for now, I think we can move forward with this. So the next thing we want to do is we want to upload this smart contract that was built to the blockchain. So what the CLI does, once you build, we want to, we're building a debug version for now, but once we're done, we want to build a release. So we issue this command yarn build release, which will generate a couple of files for us. So the files that it generates is the ABI file, and maybe Steve, can you jump in here and explain what the ABI file does?
Yeah, so ABI stands for Application Binary Interface. This file informs libraries outside of your smart contract what methods your smart contract provides. It also defines what are the argument types and the return types that you'll get from the smart contract. And it gives a little bit more information. Entry point is, it's basically a number that from outside, like in a client library, when you call the smart contract, you'll say, oh, call a smart contract at this address and this function. And that function is the entry point. It's basically the first 4 bytes of a SHA-256 of the name of the method. But you don't need to know that. It's just a convention, but this generates it for you automatically. There's also a read-only attribute. And so that will tell a client library whether when you call that particular function, does it need to be in a transaction, or can it be just called and straight through RPC and not inside of a blockchain transaction. So when you write to the blockchain, that needs to occur inside of a transaction, meaning a person will sign it and pay mana because it will change the state of the blockchain. If you just want to read information from a smart contract, it doesn't change the state of the blockchain. So read only would be true. And you could just call that through JSON RPC. It doesn't cost any mana and anyone can do it without, without signing anything. So that's essentially what the ABI does. This works with tools like the CLI. It'll also work with JavaScript client libraries. And this is all the information that the ABI file provides.
Awesome, thanks. So the main file that we're really concerned with that the release build generates is the contract.wasm file. This is where our contract is compiled to. And then these 2 files is what we want to upload to the blockchain. And in order to upload to the blockchain, I'm going to use the CLI. So let me go here and open the Koinos CLI. Again, if this is unfamiliar to you, I went over this in the first tutorial on how to set all this up. It's relatively easy. So I already created a wallet, and for the test net, you can get test coin from our Discord. So I already went ahead and did that ahead of time. So I'm just going to open, I think I call it wallet.wallet. And this is my password. Don't use password as a password. And let's just see the balance here. We have 50 T-coin. On Koinos, using the blockchain is free, but to execute transactions, you have to pay something that's called mana. Mana is a property of a coin token. It's not a token itself. So right now you'll see that once we upload the smart contract, it'll use a certain amount of mana in order to upload the smart contract to the blockchain. But that mana will regenerate after 5 days. So while the mana is regenerating, that number of tokens is locked up. So let's say, for argument's sake, it costs 1 mana to upload a smart contract to the blockchain. That 1 token will be locked up for a period of approximately 5 days. So we'll only have 49 more tokens to use for other things. After 5 days, that token will be unlocked, and then we'll have the full 50 to use if we haven't used any in the meantime. So the way that we upload the smart contract to the blockchain is issuing the upload command. I need to go back here and grab this real quick. So to-dos slash, and then we want to go into our build folder and then our release folder and then the contract WASM. That's the first file we want to upload, and the second file is the ABI. So here it's in the ABI folder, and we want to do the to-dos ABI. Oops. The to-dos ABI. Cool. So once we upload this to the blockchain, it will attach the public key of this wallet to the smart contract. So this wallet will own this smart contract. So we've successfully uploaded it, and this is the address of the wallet that uploaded the smart contract to the blockchain. And we can now interact with that smart contract through the CLI. And this is all here. So once we want to interact with the smart contract through the CLI, we have to register first. So register, and then we give it a name. We're going to call it to-dos, and then the address of the smart contract the address of the wallet that owns the smart contract. Once we're registered, we will have our functions available. So to-dos, and then let's add the first to-do. So create to-dos. Let's spell that right. So now our function is using the code that we just wrote to write our message to the blockchain. So now this create a to-do smart contract on Koinos message is living on the blockchain. We want to fetch that, so we use our other function that we wrote, which is get to-dos, and we get our value. So now this information lives on the blockchain. Again, this is a testnet, and a to-dos list is not a good use case for blockchain. I want to emphasize that. But we successfully created a smart contract that allows us to write data to the blockchain and then retrieve that data from the blockchain. This basically concludes today's workshop. We want to take questions. I see there's some stuff in the chat. Oh, Steve's already answering it. So now we can take some questions if you guys have some questions. And Steve, is there anything that I missed? Do you want to add anything?
Yeah, sure. So if you look at Ron's screen right now, you could see he called register to-dos in the contract address. And then after he issued that command, all the functions we defined were then automatically known by the CLI. That's because the register to-dos command retrieves that ABI file we talked about before. And in that ABI file, it informed the CLI, this program, that there are two methods available, and it told it what the arguments and the return values are. That's how that automatic understanding of a smart contract occurs. It occurred during that register function. Another thing that I think is important to take note is that the add to do method is not read only. And so the wallet automatically knows that from the ABI file. So when he issued the command to-dos.add to do, you see that it gets a transaction ID and it costs mana. The CLI knows to do that because of that ABI file. Likewise, it also knows that you can just call get to dos without a transaction. You can see that there's no transaction ID when it says get to dos. That's because the ABI informed it that it's a read-only function. It doesn't require a transaction. And you could just ask the blockchain and it'll answer you for free. Testnet and mainnet it's the same implementation. It always costs mana when you write a transaction. When you send a transaction, to process that transaction costs mana. So it costs mana on the test net. It also costs mana on the main net.
Right. So I think it's good to understand that in order to interact with the Koinos blockchain, you either need to hold coin tokens, or someone can delegate or pay for your transaction fees with their mana. So it's not free to transact on the network. We call it free to use because if you hold the tokens, you can use the mana, and then the mana regenerates. You never lose your tokens. Or if you use a decentralized application that was written in a way where the mana is delegated to you, then you don't even need to hold the tokens, and you're able to interact on the blockchain.